Hello viewers, in today's session we are going to discuss an important problem from three-dimensional geometry, and here we are going to discuss this problem where we have to find the distance of this point whose coordinates are -1 comma 2 comma 5 from the plane whose equation is x plus 2y minus z is equal to 2. So here the Cartesian equation of the plane is given in the form that is ax plus by plus cz plus d is equal to 0, and we have to find the distance of this point from this plane measured parallel to this line whose equation in symmetric form is given as 1 minus x over 2 is equal to 2y is equal to 1 minus z over 3, right? So here let us first draw the rough diagram of this problem, and then we'll see how we can find out the distance of this point from this plane measured parallel to the line, because the distance has to be measured parallel to this line. And here it is important to note that we don't have to find out the perpendicular distance of this point from this point, this plane, right? So let us start. So now consider the plane, and let us denote this plane by the letter pi. So here the equation of this plane is x plus 2y minus z is equal to 2. And here we have a point, say this point is A, and the coordinates are -1, 2 and 5, and we have to find out the distance of this point from this plane parallel to this line, right? So let us draw this line like this. Suppose this is our line, say L, this is our line L, and we have to find out the distance of this point A from this plane, that is pi, measured along this line L, right? So here this distance, suppose this point is B, and this distance, that is AB, is not the perpendicular distance of this point A from this plane pi. So we have to find this length, that is AB, and here the coordinates of A are known, and first we'll find out the coordinates of this point B, and then we can easily apply the distance formula to get the distance AB, right? Okay, so now here the equation of the line is given as 1 minus x over 2 is equal to 2y is equal to 1 minus z over 3. So let us now first express this equation in this form, that is x minus x1 over a, y minus y1 over b, and z minus z1 over c, right? And here we have 1 minus x, so we can now write here minus x minus 1 over 2, and here we have 2y over 1, and here we can now write negative, and then we have z minus 1 over 3, right? So now let us divide throughout by -2, right? So we have here x minus 1 over 4, and here we have y over simply minus 1, and here we have z minus 1 over 6. So the first step is to express this equation in this form. So here we have now expressed the equation of the line L in this form, that is in the symmetric form. Now if we compare these two equations, then we can easily see that this line passes through 1 comma 0 comma 1, because here we have y minus 0, right? So 1 comma 0 comma 1 is a point lying on this line L, and the direction ratios of this line L are given by A, B, and C. And here we have 4, minus 1, and 6. So the first step is to get the direction ratios of this line L, which are 4, minus 1, and 6. So now the second step is to get the equation of this line, that is AB, equation of line AB in the symmetric form, right? And the purpose of finding out the direction ratios of this line L is to get the equation of this line AB, because we already know a point, the coordinates of the point A lying on this line AB. And since we know the direction ratios of this line L, and this line is parallel to AB, right? L is parallel to AB, and we know that parallel lines have either equal direction ratios or proportional direction ratios, right? So the direction ratios of this line AB can also be taken as 4, minus 1, and 6, because this line L is parallel to AB. So the DRs of AB are also given as 4, minus 1, and 6. And we already know the coordinates of a point, that is x1, y1, z1 on this line AB. So x1, y1, z1 are given by minus 1, 2, and 5. So now we are in a position to write the equation of this line AB in this form. So we have x minus minus 1 over 4, because A, B, C are now 4, minus 1, and 6 respectively. And here we have y minus 2, and here we have minus 1, and here we have z minus z1, and z1 is 5, and for C we have here 6. So now the equation of the line AB is given as x plus 1 over 4, y minus 2 over minus 1, and z minus 5 over 6. So now the next step is to get the coordinates of this point B. And in order to get the coordinates of this point B, here we have to introduce a scalar, say lambda, where lambda is some real number. And the purpose of introducing this lambda is to get the coordinates of the general point lying on this line AB. And for some particular value of lambda, that coordinate will represent the coordinates of this point B, right? So here we take lambda, and we can find out the coordinates of the general point lying on this line AB. So now let us form three equations, that is x plus 1 over 4 is equal to lambda, y minus 2 over minus 1 is equal to lambda, and z minus 5 over 6 is equal to lambda. So now let us find out the values of x, y, z in terms of lambda. So from here we have x plus 1 is equal to 4 lambda, and x is equal to 4 lambda minus 1, taking plus 1 to this side. And from here we have y minus 2 is equal to minus lambda, and y can be taken as minus lambda plus 2. And then from here z minus 5 is equal to 6 lambda, and from here we have z is equal to 6 lambda plus 5, right? So the coordinates of the general point lying on this line AB are given by 4 lambda minus 1 minus lambda plus 2 and 6 lambda plus 5. And for some particular value of lambda, this coordinate will represent this point B. And now we know that this point B lies on this line AB and this plane pi. So this coordinate must satisfy the equation of this plane. So replacing x by 4 lambda minus 1, y by minus lambda plus 2 and z by 6 lambda plus 5, we can find out the value of lambda for which this coordinate represents this point B. So now substituting this coordinate on this equation of plane, we have now 4 lambda minus 1, then we have 2 times minus lambda plus 2, and then we have minus z here, that is 6 lambda plus 5 is equal to 2. So now we have a linear equation in lambda. So we have 4 lambda minus 1, from here minus 2 lambda plus 4, then minus 6 lambda minus 5 is equal to 2. Now 4 minus 2 is 2 and 2 minus 6 is minus 4. So here we have minus 4 lambda and here we have 4 minus 1 is 3 and 3 minus 5 is minus 2 and here we have 2. So now from here we have minus 4 lambda, taking minus 2 to this side, we have 2 plus 2 minus 4 lambda is equal to 4. Lambda is 4 over minus 4, that is equal to minus 1. So the value of lambda is equal to minus 1. So for this value of lambda, that is equal to minus 1, this coordinate represent this point B, which lies on this line AB and this plane pi. So taking lambda is equal to minus 1 in this coordinate, the coordinates of the point B can be obtained as minus 4 minus 1, and here we have minus and minus 1 plus 2, and here we have minus 6 plus lambda. So the coordinates of the point B are minus 5. Here we have plus 1. So 2 plus 1 is 3 and 5 minus 6 is minus 1. So here the coordinates of the point B are now minus 5, 3 and minus 1. So now using the distance formula for these two points, so this distance AB is now given by x2 minus x1 square plus y2 minus y1 square, and here we have z2 minus z1 square, and here we can take this point as x1 y1 z1 and this point as x2 y2 and z2. So now the distance AB is given by x2 minus x1, so we have minus 5 minus minus 1 square, then we have 3 minus 2 square, and then we have minus 1 minus 5 square. So we can now write here this is a minus 5 plus 1, so we have minus 4 and minus 4 square. Here we have 1 square and here we have minus 6 square. So we have here minus 4 square is 16. Here we have 1 and here minus 6 square is 36. So this distance AB is now equal to 16 plus 1 is 17, and here we have 3 and here we have 5. So here we have square root of 53 units. So the distance of this point from this plane, that is pi, measured along this line L, is equal to square root of 53 units.